Hello everyone. In this video, let's discuss about this circuit. Here we can see that we are taking a initially 0 voltage charged capacitor connected to a DC volt 5 volt, and in between there is a NMOS. Before thus here we need to understand that the charging of this capacitor will depend on the state of the NMOS here, whether that is off or on, whether in on region also, whether that is in saturation or linear region. So to understand this state of operation of this NMOS, let's redraw the circuit again only for NMOS here. Okay, so there is a MOS here. This is drain, this is source, and this is gate. And here we can say that gate and drain are both are shorted. And because drain is 5 volt, initially the cap is uncharged, so that I can consider source equal to 0 volt here. If I see that always VG will is 5 volt, in the same way VGS is VGS equal to 5 volt, but VTH of the NMOS here given as 1 volt, so that VGS is greater than VT. I can say that the NMOS is in on state. Okay, now let's find in the on state whether it is in saturation or linear. Let's see in what is the necessity to be in saturation. If the VDS of the MOS is greater than VGS minus VTH, then the MOS is in saturation. Here this is in saturation. In the same way, if VDS is less than VGS minus VTH, then the MOS is in linear region. Okay, so let's find what is the voltage here. So VDS I can write as VD minus VS. So VDS, then VG minus VS minus VTH. So if I rewrite this again, VD minus VS, and VG I can write as VD. Why? Because VG equal to VD voltage, and VS minus VTH. So you can say that this is VD minus VS, and this term, the second term VD minus VS, there is extra term which is VTH. So that we can say that always this will be greater than VD minus VS minus VTH. So the region of this MOS is in saturation region. Okay, we know that in saturation region MOS has a constant current source, so that I can replace the MOS with some constant current source. Okay, so if I redraw the circuit again, so here until, so for example we can say that till what voltage the MOS will is in saturation region. We can say that this equation will holds good in, until the MOS is in on. That means if VGS less than VTH, till this region, till this condition holds true, that means till MOS goes into off operation, from saturation to off, this the MOS is in always in saturation region. Okay, so that the output, if I redraw the capacitor voltage, so this is VC with respect to time. So the, because there is a constant current, so I can replace this MOS as a constant current source. Okay, so because this constant current source, let's if I rewrite the circuit again, so this is like this. So this is voltage source, and because of the MOS, it is acting as MOS is acting as a constant current source, and here there is a cap VC. So that because the constant current source is flowing to the cap, the voltage across the cap will be linearly increasing in this way, and after some time the cap voltage will get saturated to some voltage when the MOS is off. When the MOS is changes its region from saturation to off, at that voltage the MOS will uh, turn off and capacitor voltage will become stable. At what voltage of VC the MOS will turn off? Let's assume when VGS is less than VTH. So VG is always 5 volt minus VS is some VS less than VTH. VTH we know that 1 volt here. So if I find VS, so 5 minus VTH less than VS, that means if I substitute VTH as 1 volt, that means VS, when VS reaches to 4 volt, after 4 volt the MOS will go into off state. So that means the capacitor voltage will go to 4 volt and stay there. So when capacitor voltage reaches to 4 volt, the MOS will turn off, and VC or the capacitor voltage will stay at 4 volts.